Hi ladies and gentlemen, this is Ms. Skokin. We're going to talk about section 11.2, volume of prisms and cylinders. Our objectives are to learn and apply the formulas to calculate the volumes of prisms and volumes of cylinders. And in our vocabulary, volume. You have 4 warm-up questions to get started with, so turn the video back on when you're ready to check your answers. I know you probably didn't have any trouble with these, but if you did, feel free to come in and ask questions. All right, let's take a look at our first page of new notes. Volume is a 3-dimensional measurement, and we recognize this figure of a cube, and we remember that volume of a cube is side cubed, hence the name cube. In this case, our cube has a height of 3 blocks, has a width of 3 blocks, and has a depth of 3 blocks. So the side length that we're going to put in is 3. The volume of this cube is 27 cubic units. Okay, now let's talk about the volume of a prism. The volume of a prism with base area B and height h can be found by V equals B, which again is the area of the base, times the perpendicular height. We're going to try all of these formulas out, so don't worry if anything seems a little bit unfamiliar or unclear right now. The volume of a right rectangular prism with length L, width W, and height h is going to be length times width times height. And the volume of a cube, as we just saw, is going to be side cubed. In example 1, we want to find the volume of the 3-dimensional figures. The first one is a rectangular prism. We're given the length, the width, and the height of it, and so we are going to start with our formula. Volume is length times width times height, and now let's show substitution, including units. At this point, we're just going to multiply, and we're going to end up with 195 cubic centimeters. Next, we're going to find in question B the volume of a cube with length 15 inches. We've already talked about the volume being side length cubed, so we're going to show our substitution 15 inches cubed. And that means our volume is going to be 3,375 cubic inches. And now it gets interesting. We have a hexagonal prism, and we learned the formula for the volume of a prism is going to be capital B for area of the base of the prism times the perpendicular height. We have the perpendicular height already, it's 12 feet. What we need to find is the area of the hexagon that serves as the top base and the bottom base of our prism. And for that, we're going to need the apothem. The formula for the base area is going to be 1/2 times the length of the apothem times the perimeter of the hexagon. We know that a hexagon has 6 sides, and we know that the perimeter, therefore, is going to be 6 times 9 feet. And we remember that with a regular hexagon, we can break it up into 6 different triangles, so therefore the central angle is 60 degrees, 360 divided by 6. And that gives us, when we cut one of those triangles in half, a 30, 60, 90 triangle. So the length of the apothem is going to be half the length of the side of the hexagon. So in our case, half of 9 feet, 4.5 feet, times the square root of 3 because it created a 30, 60, 90 triangle. Now let's substitute into our formula. So we had to work for it a little bit, but we finally found the volume of our hexagonal prism, 2,525.3 cubic feet, because we were specifically told to round to the nearest tenth if necessary. Okay, next there's going to be a now you try on the next page, but it will be a little bit less involved than the hexagon. The question asks you to find the volume of a triangular prism with a height of 9 yards, whose base is a right triangle with legs 7 yards and 5 yards long. I strongly recommend that you start out with a diagram because it's going to make it a lot easier to figure out what's going on. And then turn the video back on when you're ready to check your answer, and then move on to example 2. The next example that we have in example 2 is a swimming pool that is a rectangular prism. We start out with a relatively simple problem. We want to find the estimate of the water in the pool in cubic feet to start with, but then we need to convert to gallons using a conversion factor. So let's start by finding the volume in cubic feet. We know the volume of a rectangular solid is length times width times height. So let's show plugging in. Units are included, and we know our units are going to be cubic feet. And we have 3,375 cubic feet for the volume of our swimming pool in feet. But we really want it to be in gallons. So starting out with the volume in cubic feet, we use the conversion factor. That says 1 gallon is equal to 0.134 cubic feet. Using the conversion factor in this way is going to guarantee that our cubic feet end up canceling out because we have one in the numerator and one in the denominator. And we find that the volume in gallons is 25,186.56 gallons. If we round to the nearest gallon, we've got 25,187 gallons. Now this problem goes on to say that the density of water is 8.33 pounds per gallon. Sounds like another conversion factor. And we want to estimate the weight of the water in pounds. We have a conversion factor that relates gallons and pounds, and we want the final answer to be in pounds. So the weight of the water is going to be equal to the gallons. I'm going to use the unrounded number that we found. So this is gallons, and our conversion factor, we want to get rid of gallons. We know that it's 8.33 pounds per gallon. So the weight of the water is going to end up being 209,804 pounds. So we saw not only how to find volume, but how to find volume using different units and converting to different units. This question mimics the example that we just did together very well. So you'll need the conversion factors from the previous page to work on this Now You Try. Turn the video back on when you're ready to check your answers. The only thing that was a little bit different about this question was that we needed to double the height of the aquarium. So if you start out by recognizing that and then plugging it into your calculation right here, you should have been fine. All right, let's take a look at the next example. The volume of a cylinder with base area B, radius R, and height h is V equals uppercase B times h, where uppercase B is pi r squared, meaning the area of the circular base of the cylinder. We've got a couple of examples to work on. And the directions say find the volume of each cylinder, give your answers in terms of pi, and rounded to the nearest tenth. So each of these questions is going to have 2 answers. Just a quick reminder that when we're working on these, we need to use the radius and we need to use the perpendicular height. So keep that in mind as we're using our formula. Speaking of formulas, let's start out by writing down our formula. Volume is area base times height, or we know we can write it as pi r squared h. So we plug in 18 inches divided by 2, and then 14 inches as the perpendicular height. We throw that into the calculator and we end up with the volume is equal to 1,134 pi cubic inches, so that's our answer in terms of pi. And then our next answer is going to be when we multiply pi through, but we're going to round to the nearest tenth of a cubic inch. So we end up with 3,500 62.6 cubic inches. And those are the two answers for part A. Question B reads, we want to find the volume for the cylinder that has a base area of 121 pi cubic or square centimeters and a height equal to twice the radius. So let's start out with a little diagram for ourselves here. So we have a cylinder, we have a radius, and we have a height that's equal to twice the radius. We've also got a circular base that has an area of 121 pi square centimeters. So that's actually where we're going to pick up with a formula. We're going to say area, which is pi r squared, can be rewritten using 121 pi. So we divide both sides by pi and we end up with 121 is equal to r squared. Take the square root of both sides and we end up with r is equal to 11. Our units were centimeters. So now we know what the radius is. We also know what the height is because the height is twice the radius, or 22 centimeters. And now we're ready to plug into our volume formula. Volume is the area of the circular base times the height. So the area of the circular base is what we were given in the question to begin with. But now we also know the height to plug in. And before we multiply pi through, we have 2,262 pi cubic centimeters. And after we multiply pi through, we have 8,362.9 cubic centimeters. And those are our two answers for question B. Next, you have a now you try to work on. And you can draw a diagram if you want to. You don't have to if you don't want to. But turn the video back on when you're ready to check your answers. And just a quick reminder, you're going to have two answers, one answer in terms of pi and the other one rounded to the nearest tenth. See you back in a minute. Okay, I'm sure you found that question very straightforward using our formula for the volume of a cylinder. In example 4, we want to see what happens when we change dimensions on one of our 3D figures. So we're going to start out by, of course, reading the question. We want to find the volume of this cylinder if we alter the radius and the height by multiplying each by 2/3. If we find the volume of the original cylinder, we're going to, of course, once again use our formula. V equals pi r squared h, and then we're going to plug in the values that we have. R is 24 inches, square that, and our height is 33 inches. And our answer in terms of pi is 19,008 pi cubic inches. And after we multiply pi through, 59,715.4 cubic inches. In order to find the new dimensions, in order to find the volume using the new dimensions, of course, we can plug in 2/3 of the original numbers that we had for the radius and the height. So let's show doing that. But that's not the only way to do this problem, because we recognize that what we're really doing is we're multiplying in 2/3 twice there and once again there. So what we can do instead is take all our final answers using the original dimensions and multiply by 2/3 cubed to get the volume of the cylinder with the new dimensions. So in the next question, when we describe the effect on the volume in a complete sentence, that's exactly what we're going to say. The volume of the cylinder changes by a factor of 8/27 when the radius and height are reduced by 1/3. Okay, now you've got one to work on where you're going to see What happens to the volume of this prism when the length, width, and height are doubled? Turn the video back on when you're ready to check your answer. We didn't actually even have to find the volume of the original to answer the question, which was describe the effect on the volume in a complete sentence. So we did have to see what would happen if we doubled the length, width, and height, but we did not actually have to calculate either one of the volumes. Example 5 is the last example in our lesson, and here we're finding volumes of composite three-dimensional figures. The instructions read, find the volume of the composite figure and round to the nearest tenth. So what we see as we're assessing what information we've got here is a rectangular prism topped by a triangular prism. So what that means is we're going to find the two volumes of the two different types of prism and add them together for a total volume. To find the volume of a triangular prism, you may remember that we're going to find the volume of the cross-section of the triangle, which is 1/2 base times the height, and we're going to multiply that by the height of the prism. Let's take a look at the dimensions of our triangle. We see we've got 8 centimeters on this side. We know we're going to have 8 centimeters on this side because of the dimension given here. And we also know, because of the dimensions given on the rectangular pyramid, that we're going to have 8 centimeters across the bottom. That means that we have an equilateral triangle. And some of our prior knowledge of triangles is going to help us out because we know we can find the perpendicular height using our knowledge of right triangles. If we have an equilateral triangle and we cut it in half, we're going to end up with a 30, 60, 90 triangle. And that means that the side lengths can be thought of as x, or in this case, 4 centimeters, which is half of the 8 centimeters, and the long leg can be found by multiplying the length of the short leg times the square root of 3. So we have our perpendicular height that we need. The base of the equilateral triangle is 8 centimeters, and the height is 4 root 3 centimeters. And then we're going to multiply that by the height of the prism, which is 4 centimeters right here. Okay, that's going to get us the the volume of the triangular prism. When we multiply all that through, we're going to have 64 root 3 cubic centimeters, and we're going to add to that the volume of the rectangular prism. We remember that we can find that by multiplying length times width times height, and that means 8 centimeters times 4 centimeters times 5 centimeters to give us 160 cubic centimeters. So we have the two volumes that we need that make up our composite figure, and when we add them together and approximate to the nearest tenth, we're going to have 270.9 cubic centimeters. Further down on the page, you've got a now you try, and on this example, what you see is a cylinder with a rectangular prism cut out of it. And it says that in our instructions. So the way that we're going to figure out the volume of this composite figure is to start out with the volume of the cylinder and then subtract out the volume of the rectangular prism that is cut out and removed from it. So you're going to be working on this. Pause the video and turn the video back on when you're ready to check your answer. Working on this question, you probably recognize very quickly that we had a square that was cut out of a rectangular prism, but we can look at that as a square on the top cross section or on the base, the circular base, and we could cut that in half, and we ended up having an isosceles right triangle, which is a 45-45. We remember the relationship between the side lengths and we were able to determine that each of those side lengths is 6 divided by the square root of 2. You could also have used SOHCAHTOA. There are a couple of other methods that you could have tried, but any which way you go, as long as you were able to find the correct volumes and then subtract, you would get the correct answer. That is it for our lesson. Time to do homework, and I'll see you back in class.